Come with me as I program a game using the power of Destiny and JavaScript. We are building the modern classic, the Flappy Bird, but better. At least I hope, if the wheel of fortune is on our side. We are improving it in 5 different ways. Using 5 fundamental techniques you can reuse over and over to create thousands of different games. Number 1, it will be fully responsive in every way you can imagine. Not like this, not like this, like this. It's really fun to take a proven game concept and put your own spin on it. This is how I would improve Flappy Bird. Built completely from scratch, step by step with vanilla JavaScript. You ready? Let's go! The game we are building will be a steampunk themed time run. The player will have a special charge ability and it needs to get through the obstacle course as fast as possible while managing a rechargeable energy bar. This game will be full screen and fully responsive. It will scale and adjust itself to any device. You can play it on your mobile phone and on your big computer screen. It's your choice. Have you decided to take your destiny into your own hands this year and finally learn JavaScript? Why not learn it on a fun animated project? As always, this entire class is vanilla JavaScript, no frameworks and no libraries, because I want us to really understand what's going on. Today, we will work with arrays, functions and for loops in an object-oriented codebase. Nothing fancy, just the basics. Fully understanding these simple building blocks allows us to build anything we want. Let me show you. This class is beginner-friendly, but a basic understanding of HTML, CSS and JavaScript is needed to get the maximum value. Main.js will contain the game class. This will be the brain of the code base. From here, we will manage the state of all other objects in the game, such as the player, the obstacles, and so on. Game class constructor will expect 2 arguments, a variable pointing to the HTML5 canvas element we just created, and a reference to its drawing context. We will explain why we need them soon. Inside, I convert them into class properties. The width of the game area always needs to be the same as the width of the canvas element, and same for height. I want to keep the project well organized, so I will create another JavaScript file. Player.js will contain the player class. Constructor will expect a reference pointing to the main game object, and now we can just use this.game to access all the useful methods and properties that will be sitting on there on the main game class. Doing this, we are just pointing to a space in memory where the main game object is stored. From this reference, we will be able to immediately see if any properties on the game object change values. We created a one-way connection between player class and game class. Player will need to be drawn somewhere on canvas, so it will need x and y coordinates and width and height. I want to draw the player on canvas. We are using multiple script files and we will be using a lot of art and images. I want to make sure that JavaScript runs only after all these resources are fully loaded, so I will create an event listener for load event. The load event is fired when the whole page has loaded, including all dependent resources such as style sheets, scripts, iframes, and images. Inside, I will set up our project. HTML canvas projects are often set up the same. It's good to remember these following 4 lines of code. First, we create a variable pointing towards the actual HTML canvas element we created in index.html. Then I take that canvas variable and I call built-in getContext method. This special method creates a so-called drawing context, which is basically a built-in JavaScript interface that contains all drawing methods and properties that we will need. It expects at least one argument, so-called context type. We can pass it 2D or WebGL. Today we are working with 2D rendering context. I take that canvas variable again and I set its width and height properties to 720 times 720 pixels. You can see it all works because my canvas resized. Using these properties is the correct way how you should resize your canvas, not in CSS. HTML canvas has 2 sizes. Doing it this way sets both element size and drawing surface size of canvas to the same values, which is very important. So this is how we set up a canvas project, and now we can use this ctx variable, shortcut for context, to draw anything we want. I remove the border here, We are building an extremely flexible game. This game will adjust to any possible screen size, vertical or horizontal. I want to make sure that canvas always fits into the visible browser area. If the browser window is not wide enough, I want canvas to scale down. The maximum width of canvas is 100% of the current browser window size. We do the same vertically. If you try to resize the browser window now, you will notice that the canvas scales up and down to make sure it's always fully visible. We will draw all game objects from a custom method on the game class. I will call it, for example, render. I will take this.ctx from line 4, and from there I call built-in fill rectangle method. This method expects x and y coordinates of the top left corner of the rectangle and its width and height. To run this code, I need to call my render method. I create an instance of the game class using the new keyword. The new keyword will look for a class with that name and it will try to find its constructor method. It will run all the code inside that constructor line by line from top to bottom. I can see that game class constructor expects canvas and context references, so I pass it canvas variable from line 14 and I pass it ctx from line 15. This will get passed as context, converted to this.ctx property, and from there we are now able to draw shapes from inside the game class. I can test if it works by taking this new game variable, which holds an instance of the entire game class, and from there I call render, we defined on line 8. We are drawing a rectangle at coordinates 100, 100. It's 50 pixels wide and 150 pixels tall. By default, canvas has a black fill style. I can change it to a different color, for example red. Now, how do we draw the player? I give the player a custom method I call, for example, draw. Inside, we access ctx property sitting on the game object, here. From there, I call built-in fill rectangle method. This time, I want to draw a rectangle representing the player, so I pass it x, y, width and height of the player, like this. I want to handle everything from one central point, from this main game class. I can actually create an instance of the player class automatically, as we create an instance of the game class. Player class constructor expects game as an argument, so I pass it this keyword, because in this area, this represents this entire game object. I also have to make sure I include player.js script in our project, and I need to make sure it comes before main.js. I need the player class to be declared before we need it inside main.js. Instead of calling this here, I will take this.player from line 7 and I will call its associated draw method we defined on line 9 in player.js. Perfect, it all works and we have a confirmation that we have successfully established a two-way connection between game and player classes. The player will be moving around canvas. We can achieve that by giving it an update method. Let's say I want the player to move by 1 pixel to the right per animation frame. I call that update method here. The update method runs just once on the first page load. We need to call it over and over again. Let's create an animation loop. I create a custom method I call, for example, Animate. We want to update all game objects, draw them, delete them, update them, draw them at the updated position, and we want to do this over and over to create an illusion of movement. I call built-in request animation frame method and I pass it animate, the name of its parent function, and I want to call it from here to start the animation loop. It looks like this because we see old animation frames. I can use built-in clear rectangle method to delete everything between every animation loop. I want to delete the entire canvas from coordinates 0, 0 to canvas width, canvas height. We are animating the player. Nice work! We are building a fully responsive game that will adjust to any possible device, to any possible screen size, and to any possible viewport ratio. That can be quite complicated to implement, but let me show you how I like to implement it with a simple trick. When we create an instance of a class using the new keyword, like we are creating an instance of game on line 26, it will automatically run all the code inside the constructor of that class, line by line, from top to bottom. We can take advantage of that, and we can put even some code that doesn't directly relate to the functionality of that class. That code also gets automatically executed at the same time when the class is instantiated. We are already kind of doing it here on line 7 when I automatically create an instance of the player class as the game class gets created. We can also add event listeners in here. I create an event listener for window resize event. I will give its auto-generated event object a variable name, for example E, and I will console log it. Every time I resize the browser window, resize event fires and it shows me the event object containing all kinds of useful information. We are calling this from the window object representing the browser window. So after we resized, I can access this current target property and I want the new resized inner width and inner height of the browser window. When we resize the browser window, I also want to automatically resize the canvas to fully cover the new resized area. I take this .canvas property from line 3, which represents the actual canvas element we are targeting on line 22, and I set its width to the new updated browser window width. I will do the same for canvas height. I will also resize the width and height properties of the game object from lines 5 and 6 to match the new updated resized values. Now, if I resize my browser window, it doesn't do it and it gives us an error. To become a good developer, it's important that we know how to read errors and how to understand what is the error trying to tell us. The error text here says, cannot set properties of undefined on line 11, set in width. This means that this .canvas is for some reason undefined inside this callback function. If you console log this keyword here, it will point to the game object. But if you console log it from here, it will actually point to the window object, because that's where we are calling this code block from. And because window object doesn't have canvas property, only game object does here on line 3, we are getting this error. It cannot find window.canvas because we only have game.canvas. To fix this, we need to make sure that this keyword inside the callback function on this event listener points to the game object, not to the window object. One easy way to do that is to turn this callback into an ES6 arrow function. One special feature of arrow functions is that they do not bind their own this keyword. Instead, they inherit the one from the parent scope. This is so-called lexical scoping. It doesn't matter what object we call them from, it matters where in the codebase we declare them. Now, this keyword used inside this callback points to the same game object, and JavaScript can finally find this .canvas property from line 3. Nice! When I resize the browser window, we can see that the blue canvas element resizes with it. I can put all this code into a custom resize method instead. And I call that method from here. Now we lost access to the event object and its properties, so I will make sure resize method expects the new resized width and height, and we pass them to it from the event object here. Again, I set canvas width and height to the new width and height values. And it all works again. I will call resize automatically as the game class gets created. And here we don't have access to the resized event object, so on the first page load, I will pass it the current width and height of the browser window. Here we are setting canvas fill style to red over and over for each animation frame. It's not a good practice for performance reasons. I commented out. Ideally, if we don't need to change the fill style color, we want to set it just once somewhere. It will not work from here because canvas state, including all its properties such as fill style, get reset to default every time we resize canvas. Default fill style is black, and we are resizing canvas automatically here. If I comment this out, you can see that the gold fill persists. Basically, I have to redeclare all the colors, line width, and all the other canvas state changes I might want to potentially do after every time I set canvas width and height properties to new values. Because setting these properties to new values, resizing canvas, resets all canvas settings to default. It's a good trick to know because sometimes you might want to do it intentionally as well. But we're not doing that here. This is very important to remember. For performance reasons, when working with HTML canvas, we want to try to change canvas state as little as possible, but we have to do it after every time canvas gets resized. We resize canvas and we set fill style after. This will work. Setting fill style here only when we resize is better for performance, rather than declaring it over and over 60 times per second for each animation frame from inside the render method, like we were doing before. Now, when I resize, we keep the red color, and we are implementing that in a performance-friendly way. I comment out this part for now. We are building a side-scroll game where the player can move up and down to avoid obstacles. This red rectangle currently represents the player. We have a blue game area that can dynamically resize to any possible screen size. But for example, what if the screen is horizontal like this? It doesn't make sense for the player to be this big. I want the player to scale up and down to always take up the same portion of the available game height on any screen size. I need to scale the player object somehow as we resize the game area. The game will have a base height of 720 pixels. It will exactly match the height of the background artwork we will use later, and when the game is this size, every object in the game will be at its original basic scale, at 1:1 ratio. If game height shrinks, I want to reduce the size of the player. When it grows, we want to scale the player up. I will calculate the ratio between the current height of the blue game area and the base height of 720 pixels. That's the baseline. Bear with me here, I will explain this in detail as we write the code. When we resize the browser window, canvas and game area also get resized, and we have to recalculate the ratio. We will use this single ratio value to recalculate the correct size for all game objects in the game: player, background, obstacles, and so on. To explain this, I will console log the height of the game area, the base height, which is always 720 pixels, and the ratio between these two values. We only care when the height changes for this particular game. If we change the width of the viewport, we can just simply show more of the game area. We don't need to scale that. When the height reduces, you can see that the ratio also gets smaller. Let's say here, the ratio is around 0.5, so I want to make everything half the base size. Base size times 0.5. Here we have ratio about 1.2, so I want the game objects to be roughly 20% larger than their base size. I give the player a custom resize method. We will be using animated sprite sheet, so I will use the size of the sprite frame as the base size. The sprite sheet I will give you soon will have frames 200 times 200 pixels. I copy these. At first we can just declare them with no value, and when we resize the player, the width will be the base sprite width times the game ratio we calculated. Same for the height. The height of the player will be its base height, scaled up or down by the ratio. Whenever we resize the game after we calculated new ratio, we call player resize as well. Now, when the ratio is around 0.5, we are multiplying the base player size of 200 times 0.5, resulting in the player being half size, roughly around 100 pixels width and height. If I go more than 720 pixels, which is the base game height, we get ratio above 1. in this case 1.2, it will scale the player roughly 20% above its base size of 200 pixels. So 200 times 1.2 ratio will be around 240 pixels. Wide and tall, because it's a square right now. If the ratio is around 1, we draw the player at its base size, because 200 times 1 is 200. For performance reasons, I think it would be good to remove some decimal points in that ratio value to make it easier for JavaScript to calculate these. Or we could round down the final scaled size of the player so we are not drawing sub-pixel values, which is always a good performance practice when drawing things on canvas. We might do that later. So this is the goal. I want the player to always take the same portion of the game height because we will be flapping up and down. We scale the size of the player based on the game height. If we resize the width, it will just show more of the game world, and in that case the player doesn't need to be scaled. I hope it makes sense. The ratio between the current height of the game and the base height of the game will determine how all objects in the game scale. Base height of the game will exactly match the height of the background art to achieve a perfect side-scrolling effect. We will do that soon. I want the player to act like a real physical object. We want to feel its weight when we play. We want some gravity to pull it down. All objects in the game will be affected by the same gravity value, so I put it on the main game class. Let's say I want gravity to pull the player down by the force of 1 pixel per animation frame. We will apply it here. If the player is not touching the bottom of the screen, pull it down by the gravity force. When it hits the bottom, it stops. This motion is very linear. The player always moves at the same speed. It doesn't feel very realistic. A better way to simulate gravity in a 2D game engine like this would be to create a helper property called speed_y, vertical speed. Initially, we set it to 0. I will apply that speed to player's vertical position for every animation frame, and be aware that it can be minus, pulling player up, or plus, pushing player down. Instead of this, I will increase speed_y by gravity, making it accumulate more and more speed the longer it falls, creating a more dynamic, non-linear motion pattern. I need to make sure the player doesn't fall through the bottom of the screen if the vertical position of the player is more than the height of the game minus the height of the player. If the bottom of the player rectangle touches the bottom of the game area, make sure it can't move any further down. I console log speed_y to check what exactly is happening. Yes, speed_y increases, making the player fall faster and faster until it eventually stops increasing when this check is false. We are checking if the player is touching or not touching the bottom of the game in multiple places. I want to make the code more readable. It will help us as the codebase grows. I will have a simple utility method that will return true if the player is touching the bottom of the game area and false if it's not. I will use it here. And here I say only increase speed_y by gravity if isTouchingBottom method returns false. Exclamation mark means false. If I write my code like this, it's easier to see at a glance what each code block is doing, I think. The size of the player rectangle is not the only thing that needs to scale up and down depending on the game ratio. I set the starting x to 20, 0. You will notice the player will fall across the available game area much faster if the game is scaled down. When the player is small, it's moving by 1 pixel per frame still. We need to scale the gravity by ratio as well. Initially, I will just define it here. Here, after we calculated the ratio, we set gravity to 1. I delete this. Actually, I want the gravity to be much less to make it fall slower. And times this new recalculated ratio. Now it's perfect. The player takes around the same time to fall from the top of the screen to the bottom when it's scaled up and also when it's scaled down. We can have some fun with it. Look what happens when I set the initial speed y to a negative value. We get a little push up and then it gradually gets pulled down by gravity in a non-linear motion pattern. I want the player to start from the middle of the game area, so when we resize, rescale and reset the player to the middle of the new resized game height, and we have to offset it by a half of player's new resized height to make sure it's perfectly centered. Yes, when we resize and reset, we will set speed y to -5. We are defining speed y and this.y here, and this resize method has to run before the player is drawn, so I will not define the values in here to avoid unnecessary duplication. First, we declare the properties, then, as the game starts, resize method on the game class gets triggered here on line 15, which resizes the game, adjusts all properties to the current screen size, and then it calls resize on the player as well. In this project, resize method kinda serves as a start and restart method as well. It will make more sense as we continue, so bear with me. We are not scaling this push force, and -4 is disproportionately strong when we are on a small screen like this, for example. So I have to scale this push by the current ratio as well to unify the motion pattern and make it relative. If you still don't understand why we are getting motion like this, look at this. We have a gravity that is always pulling the player down. This is basically adding itself to the player's vertical speed. We push the player up by setting vertical speed to -4, making the player move 4 pixels per animation frame in the negative vertical direction, upwards. But as the animation loop runs, and speed y accumulates gravity, we are saying speed y plus gravity here, we are causing speed y to increase gradually from -4, which pushes the player up, to 0, to speed y 0, at which point the player reaches the peak of its jump, and then it keeps increasing, pulling the player down stronger and stronger, until we hit the bottom. Now we can maybe increase it to -8. You can also use this logic for jumping games. There is a source code from this stage available to download in the resources section below if you need to compare your code to mine. It might help you to debug and to make sure we have the same base code structure so far. Same as we are implementing resize event listener here, we will add some mouse controls down here. I want the player to be controlled by mouse, keyboard, and touch and swipe events. Mouse down event fires when we click the mouse button. This time I will apply it to the canvas element using the reference we have up here on line 3. When I click, I get this auto-generated event object in console. We are building a Flappy Bird game, so when we click the mouse, I want the player to flap its wings. I give the player a custom method I call flap. Inside, I set speed y to some negative value, for example -5. When mouse down event fires, we call this.player.flap. Every time I click, the player gets pushed upwards. I can actually push the player too far up, so I will create a helper method to check if the top of the player rectangle is touching the top of the visible game area. I only want to give the player a push when it's not touching the top, when this is false. Yes, it means we can still push a little bit outside the area up top, but we cannot leave the screen completely. Again, this push needs to be scaled, otherwise it will be too strong on small screen sizes, so let's put it in a variable. I call flap speed. We will set it to, let's say, 5 pixels per animation frame, and we scale that times game ratio. And now I can use it here inside our custom flap method. The goal is that it should take approximately the same number of clicks, flaps, to get it from the bottom to the top on any screen size. I also want to call flap when we press a key on the keyboard. Event listener for a key down event. I console log the auto-generated event object, and we are looking for this key property, which holds a name of the key that was pressed. Now I'm console-logging it. Spacebar is just an empty space character, and enter is spelled with a capital E, which is consistent on both Windows and Mac computers. So I can say if e.key is spacebar or e.key is enter, call player.flap method. Now I can press spacebar or enter, and I can play the game that way. We also want this to be fully playable on mobile phones and tablets, so we will listen for touch events. Touch start event. I console log the auto-generated event object. This is Google Chrome browser, so this small icon here allows me to emulate mobile devices. I click Toggle Device Toolbar, and I can select some phones and tablets from this drop-down. The emulation is not 100% accurate, but it's enough for prototype testing here. When I click like this, it triggers a touch event, and it seems that it's also triggering the mouse down event at the same time, which can be useful. I'm not sure how reliable that is, so for now, before I test it on an actual device, I will call player flap from here as well, just to be sure. That still works. We have mouse controls, keyboard controls, and touch controls. We will expand these code blocks as we develop the game further. We know it all works so far. We will be using images and sounds. I will put them inside a div with a class of assets. I put all my images into my project folder, into assets/images subfolder. You can download 2 background images in the resources section below. I give the first one an ID of background, and I point its source towards the PNG image file in my project folders. I remove the blue background, and we can see the IMG element is being drawn here. I don't want to draw it like this, so I will hide the entire assets folder and all its contents by giving it display none. We want to draw that background image, but with JavaScript instead. To keep it nice and organized, I create a new file in my project folders inside assets/scripts. Here we will handle another custom class I will call, for example, background. Constructor will expect a reference to the main game object again, and through it we will be able to see all the important things that we store there, like the scaling ratio and so on. I give it this.image property, and I point it towards that IMG element we just imported, using its ID. The background images I will be using are 2400 x 720 pixels. It's important that the values we use here exactly match the size of the background image we will be using. And if you are using different sized images, it can be done, but be careful. Maybe if you are a beginner, just use my images for now, and when you have the project working and you know the code is right, you can replace them for your own. To make the scaling work correctly, the height of the image and the base height of the game need to be the same value, so I might as well use that variable here. The background will be scrolling horizontally, so it will need this.x property. It doesn't need this.y because it will always take up the entire screen size, so the vertical coordinate will always be 0. It will start from the top. I give it custom update and draw methods. All the objects in our game will have these 2 methods. HTML Canvas has a built-in draw image method. It expects at least 3 arguments, the image we want to draw, and x and y coordinates where to draw it. So I pass it this.image, this.x, and vertical coordinate can be hard-coded 0 because the image will always start from the top of the visible canvas area, from vertical y coordinate 0. Let's draw this to see what we have. I create an instance of the background class as this.background property. I pass it this, representing this game class. Inside render, I first update and draw the background. Then I draw and update the player. Calling player after will draw the player on top of the background. Otherwise, it would be behind that large background image and we wouldn't even see it. I get an error because I also have to include background.js script file here. The order of these files can be important with the way we are structuring this project today. It's not drawing anything yet because this.x has no value. JavaScript doesn't know where I want the image to be drawn. I give it a resize method. When we start or restart the game, I want the background to slide back to the beginning, to this.x 0. When we resize the game, we resize the player and we resize the background. Everything needs to be always scaled correctly. In the following technique, we will discover how to implement endlessly scrolling backgrounds. The main thing you need is a seamless image. When I put two of these identical images next to each other, they should continue naturally, with no visible line, where the first one ends and the next one begins. I'm giving you these background images in the resources section below, but if you are making your own, make sure your image is seamless. We are calling this update method once per animation frame, so presumably 60 times per second, unless you have some kind of high refresh rate gaming screen. We will move the background image to the left. If it moved to the left so far that it's completely off screen, we set it instantly back to its original position. For every animation frame, I will reduce horizontal X position of the background by 2, making it move 2 pixels to the left per animation frame, or 20 pixels. We can make it scroll fast or slow, which will be handy when we give the player some special abilities and we want the game world to respond to that. We are moving the background to the left. When it's completely hidden off screen, it instantly resets back to 0, to its original position. The speed at which the game is scrolling will be used by other objects, so I will define it as a class property here. I give it a value of 3 pixels per animation frame here inside the resize method, and we can now use that speed here. Right now it doesn't scale at all, we are just moving the entire background image drawn at its full size. I give it scaled width and scaled height properties. So these properties represent the actual size of the image we are using. These properties will adjust to the current screen size and we will draw the background images at this scale. We already did most of the hard work. Whenever we resize, scaled width is the base width times game ratio. Same for the height. DrawImage method can accept optional width and height as fourth and fifth argument, and it will squeeze or stretch the image to fit this predefined area. I can pass it any values I want here. Look at what happens when I pass it scaled width and scaled height. And here I want to reset back to 0 when the scaled width value moves off screen. And now, when I make the window larger, it still works. Nice! I want to make sure it always scrolls at the same relative speed. Look at how fast the player reaches this lamp. And now, when I make the screen larger, it takes the player much longer to reach this steampunk street lamp. So as always, we need to scale the speed at which the game scrolls by the game ratio. Now, it takes this long to reach the lamp on a large scale, and I would say it takes around the same time on a small reduced scale. Perfect. Finally, how do we make it look like a big, uninterrupted, seamless game world without this white space? Simple trick. We draw the same image multiple times and we offset its horizontal X position. I draw the same image again, but its horizontal position will be this.x plus scaled width. So the second image starts where the first one ends. And because both of them feed off the same horizontal X value, their scroll speed and reset time is perfectly synchronized. To better illustrate how this works, I can include a second identical image, but I made the second one black and white. You don't have to do this part, you can just watch what happens when I do it. So background 2 is black and white. I import it here as this.image2 property. And we use this.image2 as the second image. Right, so we see the first image, and here we see where the first one ends and the second one begins. The second one will probably not show entirely. It's there just to fill the gap until the first image slides all the way off screen, at which point it instantly resets back to position 0. Now, it depends on the viewport ratio how much of the second image we will see. The second image is there just to patch and cover the white gap until the main first image is able to reset. Now, There is a little bit of imperfection between the two images, probably because I'm scaling them, so there is a sub-pixel gap. I can round the scaled sizes down, or maybe I can just do a crude fix for now. -2 pixels here should fix it. I'll have another look at this later. When we resize the game width, we just show more of the game world. If we resize the height, we scale everything to make sure it matches the new resized game area. It's unlikely that you will get a device that is so horizontal that you get to this scenario, but if for some reason you want to make sure it works even here, I can simply say if the width of canvas is more than the width of the scaled background image, simply we draw a third one to cover that white part again. This one starts from this.x, this one from this.x plus scaled width, the third one from this.x plus scaled width times 2. Color image, black and white image, color image. Image 1, image 2, image 3. I don't think we need image 4. This is more than enough. I reduce this gap by just 1 pixel and this one by 2. Should be fine for now. Not the best way to do it, I will fix that later. Now that we saw visually what is happening, let's make all 3 of them the same image. And this is how you create endlessly scrolling seamless backgrounds. I set the base game speed to 2 pixels. I create a new file inside my assets/scripts folder called obstacle.js. Here we will define our obstacle class. Constructor will expect game and horizontal x coordinate as arguments. I do this because I want the obstacles to be spaced out evenly, so each one will be placed depending on the position of the one that came before. Let's say I want them to be exactly in the middle of the screen vertically. I will actually need the height to be declared before this, so we can use it here. Width and height. Actually, we will be using a sprite sheet where each frame is 120 times 120 pixels, so I will call the base size values sprite width and sprite height. Scaled width and scaled height are the values at which we will draw obstacles on screen, depending on the current viewport size. As usual, scaled width will be the base width times game ratio. Scaled height will be the base height times game ratio. And here we offset by scaled height. Same as we did before, we give it update, draw, and resize methods. When we resize, we set scaled width and scaled height to the new resized values. I want the obstacles to appear static in the game world, so as the player moves and the game world slides, they will scroll from right to left with the game world at the same game speed value. Draw method will just draw them as simple black rectangles for now. I will need some helper properties here. This.obstacles will be an array that holds all currently active obstacle objects. Let's say I want to create 10 obstacles. We will have a helper method I call createObstacles. Whenever this method runs, it will first set this.obstacles to an empty array, in case there are some objects in it from before. I will create a helper block scoped variable here called firstX, the horizontal position of the first obstacle. Let's say I want it to sit at 100 pixels from the left horizontally. This is basically the left margin from where the obstacles start. And I want the obstacles to be spaced out every, let's say, 100 pixels. I create a for loop that will run 10 times because we set number of obstacles to 10. Every time it runs, we push new obstacle object into this.obstacles array. Built-in array push method in JavaScript will take whatever we pass to it and it will add it to the end of the array. I can see each obstacle object expects a game reference and horizontal x position as an argument, so I pass it this game object we are inside of right now, and I pass it first x, the position of the first obstacle, plus index of the for loop times obstacle spacing value. So the first one is I is 0, 100 plus 0 times 100 is 100. The first obstacle will have horizontal x position of 100. Then I increases to 1. 100 plus 1 times 100 is 200. The second obstacle will be sitting 200 pixels from the left before it starts scrolling. I increases again. 100 plus 2 times 100, 300 pixels, and so on. As the for loop runs, it spaces the obstacles out as we multiply each one by the increasing index value. So up here we have those helper properties. When I resize, start or restart the game, I will run this new create obstacles method we just created that will delete all old obstacles if there are any, and it will space the new set of obstacles out in the available potentially resized game area. Then, once we filled that array, I will call for each method, and for each obstacle object in the array, I will trigger their resize methods, which, as we can see on line 17 in obstacles.js file, will scale them up or down depending on the game ratio. Basically, when we resize the game, same as we have to resize the background and the player, we also have to resize all obstacle objects. Inside render method, we want to update and draw all obstacle objects. We have an error here. Can't find the class because I haven't included my obstacle.js script file here yet. I just put it here. Maybe blue fill style. We can see the individual blue obstacles. The obstacle rectangles scale in size, but when I do this, it becomes apparent that also the spacing between them will have to scale. I want the first obstacle to start at the same relative position on any scale, so I can come up with a new value and I can scale that value inside game resize method, or I can use some existing value we already have and I apply the current game ratio to it. I can actually apply the ratio from here because I don't have to do it inside game resize, because every time we resize, we reset the game and we create a new set of obstacles anyway. So the first obstacle will always be positioned horizontally from the left edge at the value of the current scaled vertical game height. That will give the player the same room for movement on any screen size when the game starts, before they have to deal with the first obstacle. Spacing between each obstacle will need to be larger, let's say 600 pixels times game ratio. Now, the obstacle size and positioning is consistent across all screen sizes. Is it getting easier as we progress with the project? I hope you are feeling more comfortable with the code now, as we are getting familiar how everything works and we are repeating the same scaling pattern for all our game objects. Let's make it a bit more challenging. Instead of static obstacles, the player will have to avoid obstacles that move up and down. For every animation frame, I increase vertical position of each obstacle by its speed y value. Let's say speed y is plus 2 pixels per animation frame. They just fall off screen fast, so let's make them bounce. When you want to animate endless bounce, just apply speed to a coordinate, define two boundaries, and whenever we reach a boundary, switch the speed to the opposite. So if the obstacle touches the top, or if it touches the bottom, in both cases, just flip the vertical speed. If it's currently plus, flip it to minus. If it's minus, flip it to plus. Now we have a row of fast-moving bouncing obstacles. What if I want some obstacles to start moving up and some to start moving down, to desynchronize their motion pattern? I can use a so-called ternary operator here to do that. JavaScript ternary operator used like this is basically a simple one-line if-else statement. Math.random called on its own like this will return a value between 0 and 1. As we create each obstacle here, I can say if math.random returns less than 0.5, roughly 50% chance, give this obstacle speed y minus 1. Else give it speed y plus 1. So if this condition is true, question mark, make the obstacle move up, else, colon, make the obstacle move down. I could have also done a traditional if-else statement here, but in JavaScript we can do this and get a simplified one-line syntax. Notice that they move fast on a small screen and slow on a large screen. It's because we hard-coded a speed of 1 pixel per frame, and that is disproportionately larger on small screen sizes. So again, as always, we factor in the current game scale ratio here and here. Now, as the obstacles move, they cover the height of the game area in about the same time on small screens and on large screens. Everything is consistent so far. I could also, for example, randomize where on the vertical axis the obstacles start. It needs to be somewhere in the game area, so a random number between 0 and game height minus the height of the obstacle rectangle, because they are drawn from their top left corner. Now they are even more randomized and completely vertically desynchronized. I give each obstacle a property I call marked for deletion. Initially I set it to false. I create a helper method called isOffScreen to make the code more readable. We will need this check in multiple places around the code base. It will check at first only if the obstacle moved to the left far enough to touch the left edge of the game area, and it will return true or false. If isOffScreen returns true, we set marked for deletion on the obstacle to true. We want to remove the obstacle from the obstacles array, and we want to give the player a score point for successfully avoiding it. I can remove the obstacle we just marked for deletion by filtering this.obstaclesArray. ArrayFilter method creates a copy of an array, filtered down to just the elements that pass the test implemented in the provided function. I will write this down and then I will explain the logic. We are saying filter the obstacles array and only include those obstacle objects that have marked for deletion property set to false. Exclamation mark is false. This means that this one that we just set to true will be left out and removed. Filter method returns that adjusted array, and we assign that new filtered array to the original array, overriding it. Every time this block runs, I will console log the length of obstacles array to check if it works. We start at 10 obstacles. This one should get removed about now, and we log 9. Let's wait for this one to slide far enough. Now we only have 8 obstacles left in the array. That works. Let's count score. I define this.score property here. Whenever we resize, start, or restart the game, we will set score to 0. I will also set game over to false. I define that property up here. One thing we can do is that I will only continue animating if that game over property we just defined is false. If some kind of event sets game over to true, the game should freeze. Let's say when the length of obstacles array is less or equal to 0, when the player successfully moved past all the obstacles, we win the game and game over is true. Just for testing, I set number of obstacles to 1 to get to game over faster. Obstacle touched the left edge, game over was set to true because there are no more obstacles and the game froze. That worked. If I have 2 obstacles, when it touches the left edge, it gets deleted and we have 1 left. When that one gets to the left, we have a game over again. Nice. Now I know it works, and I will actually make them slide behind the left edge all the way, so they are completely hidden before they are removed. I want to draw score, timers, and game over messages. I will handle that from a custom method I call, for example, drawStatusText. Canvas fillText method takes at least 3 arguments: the text we want to draw and x and y coordinates of an anchor point in relation to which the text will be drawn. The text I want to draw is a static string that says score, :space, plus we add a dynamic variable value coming from this.score. X and y coordinates will be, for example, 10, 30 for now. I call drawStatusText from inside render. I will slot it on top of the background, but behind the player and obstacles to make it a bit more interesting. We are drawing score. I could use a custom font if I want. For example, I can go to Google Fonts and I choose some font I like from there. I like this one called Bungee. I select it here, and then I need to copy all 3 of these link tags. I paste them into my index.html file before the style sheet. I open the CSS style sheet and I will assign that new font to all my elements in this case. I can copy font family CSS rule from here. We know that when we resize canvas, everything, all canvas state, all its properties get reset to default values. So I have to define my canvas font here after we resize canvas. Canvas font property is 15 pixels bungee. And here we go, we are using a custom font. If you don't want to use these special fonts, you can always use Impact or some other web-safe free fonts here instead. When the obstacle moves off screen and gets deleted, I increase score by 1. Let's see. I play. I don't have to avoid the obstacles now because we haven't implemented collisions yet. When the obstacle moves off screen, the score increases and we draw that new value here. Perfect. I actually want to draw the score in the top right corner instead, so the horizontal position is game width minus, let's say, 10 pixel margin from the edge. Now we broke it, so I want to change the text alignment, but I want to make sure the new text align only affects score and not any other text I will be drawing later. So I will wrap this between save and restore built-in canvas methods. These two methods will limit any changes I make here to canvas state to the area between these two lines of code. Now I can set text align to right. For now, I will cut it from here and I will only do it here when we resize to save performance. Because resize method runs only when we resize, render method and draw status text method runs over and over 60 times per second. Let's see if we can keep it here or not as we develop the project further. This game will be a time run. Player has to use special charge ability to manage energy efficiently to get through the obstacle course as fast as possible. We will display the timer in seconds in the top left corner. Score is right aligned, so after we draw it, I have to change text align to left to draw the timer here. For now, I will leave this.score property here as a placeholder. I will create a helper variable here that will store the value of the timestamp from the previous animation frame. We are using built-in request animation frame method, which auto-generates timestamps for us. It passes that timestamp value to the method it calls, so to use it, I just need to give it a variable name here. JavaScript will know that I want that auto-generated timestamp. The timestamp is a value in milliseconds since the first request animation frame in this sequence was called. We will use these timestamps for multiple things in our codebase. For example, to time regularly repeating events. If I want something in the game to happen, let's say every 3 seconds, this technique is perfect for that. I will create a block-scoped const variable I call delta time. Delta time is the difference in milliseconds between the current timestamp and the timestamp from the previous animation loop. Delta time tells us how many milliseconds it took our computer to generate this animation frame. Request animation frame automatically adjusts the speed at which it serves animation frames to the screen refresh rate, and for that reason it's better to use it rather than to use set interval to create an animation loop. There is no point to calculate and draw more animation frames than whatever our screen can display. Calculating positions and drawing those additional frames would be wasted because they would not get displayed anyway. Once we calculated delta time, we set last time to the current timestamp so that it can be used in the next animation loop as the old timestamp. Now I have my delta time value, which I can do many things with. I will pass it to render. Up here, I make sure render expects that value and I will console log it to check if everything is working. My delta time is around 16.6 milliseconds. We know that request animation frame is automatically adjusting the speed at which it serves animation frames to my screen refresh rate. 1000 milliseconds divided by 16.6 is around 60. We are animating around 60 frames per second. If you have high refresh rate screen, your delta time will be lower than 16.6. In theory, if I add a lot of graphics and animations and I run this on an old, weak computer, delta time could increase if the computer is struggling to update and draw too many game objects, for example. I create a property called this.timer. Here we set it to 0. As the game runs, we will be accumulating delta time, telling us exactly how many milliseconds passed since the game started. I will draw this .timer value here. That works, nice. I want to display the time in seconds. I can create a helper method I call formatTimer. It will return the current value of the timer times 0.001 because 1 second has 1000 milliseconds. Then I use this .formatTimer here instead. And now I want to display, let's say, only one number after the decimal point. So I can use built-in JavaScript toFixed method. I think this looks much cleaner. Let's display game over messages. If game over is true, I call fillText, and the text to draw is game over, and x and y coordinates will be exactly in the middle of the game area. To test it, I set number of obstacles to 1. We get a game over, the game freezes, but there is no message because that animation frame with that message never gets drawn. We are not calling another request animation frame after game over happens. I can change this in many different ways. I will keep animating even after the game over. I play. When the obstacle is removed, we get game over. As we explained before, Canvas fillText method takes the text we want to draw and x and y coordinates of an anchor point in relation to which the text is drawn. Where the text sits in relation to that anchor point depends on two Canvas properties, text align horizontally and text baseline vertically. For the game over messages, I will set text align to center. I also want a larger font, 30 pixels bungee. When game over happens now, the game doesn't freeze, but I still want the timer to stop counting. So here I say only increase timer by delta time if game over is false. I test it, I play, we get game over and a big centered align text and timer stops counting. Perfect. I can make the blue player rectangle directly collide with the blue obstacle rectangles using a simple collision detection formula between two rectangles, but sometimes if you use graphics in your game, you want to be able to move the collision area of your objects around independently of the object itself. You want to make the collision area smaller or larger than the object. Maybe parts of the player are sticking out of the collision area. We don't want to check collision on the tail or on the whiskers, for example, things like that. For that reason, I will give my rectangular objects, which will turn into images later. Images on Canvas are also basically rectangles. I will give them circular collision areas, which will work great for this game. For clarity, I will give these properties long names, just because this is a tutorial and I want you to have clarity which properties are doing what. I'm naming everything very explicitly. Each object in our game that is involved in collision detection will need collision X and collision Y properties, which will define a center point of a collision circle, and collision radius will define the size of that collision circle. For now, I will set collision radius to scaled width. I need to make sure that the collision circle moves around the game with X and Y coordinates of the object itself. To draw a circle on Canvas, we have to start by begin path. Arc method takes X and Y coordinates of the center point, radius of the circle, start angle, and end angle. Arc method just maps a path. It doesn't directly render anything on Canvas, so we have to call fill or stroke method to actually draw that circle. I reduce the collision radius. I set line width to 3 pixels, stroke style to white. Rectangles and images on Canvas are drawn from the top left corner. X and Y coordinates define this point. Circles on Canvas are drawn from the center point. To align the circle over the rectangle, I need to add half of the scaled width, like this, and half of the scaled height. Now they are perfectly aligned. I want to do the same thing for the player. I give it collision X, collision Y, and collision radius properties. Collision X can actually be defined here because the player will be moving up and down vertically, but horizontal X position actually never changes. With player, this is the base width and height. This is the scaled width and height. When we resize, we need to resize the collision radius. The player moves up and down, so we will make sure that collision Y follows this.Y. I can actually copy these 3 lines of code from obstacle.js because player has collision properties with the same name. My code editor tells me something is wrong. I see, I misspelled collision radius. I actually have to remove this from here because we will be accounting for width that can resize. Collision X is this.x plus half of the resized width. Collision Y will have to update for every animation frame as the player moves up and down. This.Y plus a half of the player's scaled height. I resize the window to see if the collision circles stick to the objects. Seems all good so far. So we have a blue area where we can draw the player and obstacles to look as anything we want, and we have collision circles drawn over it. On the edges of these circles is where we will be detecting collisions. I will put that logic into a separate method. Our custom check collision method will take circular object A and circular object B as arguments, and it will return true or false. To check if 2 circles collide, we first have to measure the distance between their 2 center points. To get a distance between 2 points in a 2D space between the center point of circle A and center point of circle B, we have to create an imaginary right triangle. We calculate the distance between these 2 points on horizontal x-axis. I call that dx. We calculate dy, the distance on the vertical y-axis. That gives us 2 sides of a right triangle. This is the right angle, and we know that the hypotenuse, the longest side of the right triangle, is the actual distance we need. We can calculate hypotenuse using Pythagoras theorem formula, which would look like this in JavaScript. dx squared plus dy squared, and we get a square root of that. There is even a simpler way because we are in JavaScript environment. We can use built-in math.hypotenuse method. It takes dx and dy as arguments, and it will calculate the length of the hypotenuse for us. So this is how you calculate the distance between 2 points in a 2D space. A very useful technique for so many things. Now, to check if the circles collide, we need to get sum of their radii. Radius of circle A and radius of circle B. If the distance between the 2 center points is less or equal to the sum of radii, we know the circles overlap or touch, so collision is true. If the distance is more, we know there is no collision. I can check if player and obstacle collide, for example here, inside update method on obstacle class. If this.game.checkCollision method is true, I pass it this obstacle object and this.game.player. If this obstacle and player collide, we set game over to true. I will also set a flag on the player to true. I will call it, for example, collided. It will help us to signal a few things as we develop the project. I define it here. Whenever we resize, start or restart, we set collided back to false. So at this point, we wrote some logic to win the game when all the obstacles have been avoided and deleted, and we have some logic to lose when player collides with an obstacle. We will have dynamic messaging here, message 1 and message 2. If game over is true, we check if we won or lost. If player collided with an obstacle, we know that we lost. Else if the player didn't collide and the length of obstacle array is 0, we know that we won. If we lose, message 1 will say getting rusty to keep with the mechanical steampunk theme. Message 2 will say collision time, and we display the timer value plus seconds. If we win, again something thematic, maybe we say nailed it. Message 2 will say, can you do it faster than, plus timer, plus seconds. We want the player to try again and beat their time. Try to do it even faster next time. So when game over happens, we determine if we won or lost, and we will define some messages. Then we actually draw them on canvas. I need to space them out vertically, maybe -40, -20. The second message will be drawn in a smaller text. I also want a third message that will always be the same, regardless if we won or lost. It will say press R to try again. We will implement restart functionality soon. We are getting there fast. I try to win. Nice, I get a set of 3 winning messages. We did indeed nail it. If we collide, getting rusty, that's the losing message. Great work if you are still following along. I hope you are getting a lot of value and getting ideas how to implement all of these techniques in your own unique games. We are building a Flappy Bird game, but better. Let's make it more fun, dynamic, and give the player more control. I want the bird to have a charge ability where it speeds up, but we need to make sure it cannot be used non-stop. It will be limited by energy. Or maybe I should have called it petrol or fuel to go with the steampunk theme. Starting energy will be 30. Max energy will be 60. Minimum energy will be 15. I want to display the energy. I create a for loop. We will cycle in a for loop, and for each energy point, I will draw a small rectangle. We know that fill rectangle expects x, y, width, and height, and it will draw that rectangle on canvas. Right now, we are drawing many rectangles that just overlap. If I include the index from the for loop and some spacing value, they start to align next to each other. Left margin, index as a multiplier, and spacing. If spacing is more than the width of a single rectangle, we will start seeing spaces between them. I make them wider. I will put this logic in a separate method to keep it clean. If the current energy is less than max energy, keep increasing energy by 0.1 per animation frame. I will call this.handle energy from here for every animation frame. We have a way to replenish energy. Now, how do we deplete it? By a special player ability. I can do many things here. I can, for example, make the player shoot flame to destroy the enemies or obstacles. That could deplete the energy. In this case, I will make the player charge and move faster. While it's moving fast, it's burning more fuel. It will be depleting energy that way. The charge will have some sound effects and special sprite animations, so to easily handle all of that logic, I will create 2 helper methods, start charge and stop charge. When the player charges, I actually want the entire game and all game objects to fly by faster. To create this dynamic scrolling speed that responds to player actions, we will need some helper properties. Base speed, min speed, and max speed. These values will control the speed at which the game background and the game world is scrolling. This will be the currently active speed. Min speed will hold that base value and it will store it as the minimum speed. Max speed is the minimum speed times 5, basically. So we have the minimum speed, maximum speed, and the currently active speed. We know that the current value of this.speed property changes how fast we scroll. So now we can just assign it min speed and max speed whenever we need. When we start charge, we set the current speed to max speed. When we stop charge, we set the current speed to min speed. Inside key down event listener, if the key that was pressed is, for example, shift, or if the key is C, I will call built-in lowercase JavaScript method, so this line will work for both capital and lowercase letters. I want to give each command 2 keys. Space or enter is flap, shift or C is charge. We could also do a split screen co-op, have 2 Flappy Birds on the same screen, one controlled by a mouse, one controlled by keyboard, or one controlled by the left side of the keyboard by the letters and the other by the numeric section on the right. Local co-op game like that would be very easy to implement in this codebase. When I press Shift or C, I call start charge. This method will set game speed to max speed, making the game scroll faster. Inside handle energy, I create some logic that will end charge when we run out of energy. If this.energy is less or equal to 0, first, we make sure the energy can't drop any lower, otherwise it would take much longer to recharge. And we call stop charge, which will set the game speed back to min speed. Now I need to make sure that we are using up the energy while charging. I add a simple state flag variable. When we start charge, this.charging will be set to true. When we stop charge, we set charging to false. At this scope, this is an acceptable solution, but if you want to give your player more special abilities, I recommend using state design pattern instead to keep the code clean and modular. I show how to use it in my other classes if you're interested. This game is simple enough that I decided not to use it here. I define charging as a class property here. If charging is true, we decrease energy by 1 per animation frame. Also, this code block can be in here to be more optimal. No need to check this all the time, only when we are charging. We have a replenishing source of energy and we can press Shift or C to activate charge ability. The speed at which the game world is scrolling will change based on that ability. When we run out of energy, the charge ends automatically. I can draw the energy bar in a different way. Maybe I want to stack the energy segments vertically instead, so I can use this argument. The height of the game area minus 10 margin minus 2 pixels spacing times index. Each bar will be 15 pixels wide and 2 pixels tall. This is what we get. It's partially hidden by the blue player rectangle, but it will look better when we replace these with images. We have a vertical energy bar. I can make it turn different colors to better signal the player, because one of the main parts of the gameplay loop will be to manage this energy pool efficiently to get the maximum of this special charge ability to beat the timer. Let's say I want to signal to the player that we are running low on energy. If energy is less or equal to 20, we turn the bar red. Player will be warned that the charge will finish soon and that they need to plan for that when navigating in between obstacles. Also, it's not optimal to have a full energy bar because we are wasting charges. If we are on maximum energy, we turn it, for example, orange-red. You can use a different color here, it's up to you. The only way to end charge is to run out of energy. I want the player to be able to manually end charge if needed. Let's say that flap action will stop charge. I play, I charge, I interrupt the charge by pressing a spacebar or clicking mouse to flap. This gives us much better control over the player movement and positioning. I want to make a game that feels good to control. I will stroke the player rectangle instead. If I make the screen smaller, the energy bar takes up a disproportionate screen area. Let's make this size dynamic and scalable as well. Bar size property will define the size of a single energy block in the bar. We will scale the bar size by game ratio. I use bar size as the spacing value and the height value. Here. Math.ceiling will round the values up. We want to avoid sub-pixel values wherever possible, and we are getting a lot of these in this project, because we multiply everything by the same ratio. I might have another look at that in a cleanup section later. Maybe I want the width of the energy bar to scale as well. I can do bar size times 5. Now it's consistent across different screen sizes. What if I round this down with math.floor instead? If I comment this fill style out, we will get a default black fill. When we make a project like this, a lot of things are tied to screen refresh rate. The energy is recharging faster on high refresh rate screens because request animation frame method we are using adjusts itself. It adjusts its rate to the device screen. We are setting energy recharge frequency based on animation frames. Let's set it by milliseconds instead to make the rate at which we deplete and recharge energy consistent across devices. We can also use this periodic event for other things, for example to serve horizontal animation frames, if we have a sprite sheet like that. This event timer will be universal and can be used for multiple things in the project at the same time. Let me show you. So I created 3 helper variables: event timer, event interval, and event update. Event timer will be accumulating milliseconds from delta time until it reaches interval value. Then it will set event update to true, and we will trigger all our periodic events we want to happen every 150 milliseconds. I put it in a separate method I call handle periodic events. This method will basically set event update to true every 150 milliseconds or whatever value we set event interval to. If event timer, which starts counting from 0, is less than event interval, which we set to 150 milliseconds, keep increasing event timer by delta time. Delta time is the number of milliseconds it takes our computer to generate one animation frame. As this method gets called for each animation frame, event timer is accumulating delta time until it reaches 150. All this time we want event update to be false. Else, meaning we accumulated enough delta time, every 150 milliseconds we reset event timer back to 0 so that it can count again, and we set event update to true. I'm going to console log word time just to check if it works. I need to call this method for every animation frame, so from inside render. It expects delta time and it will be passed from here, so all good. We are getting the console log. What if I want this repeating event to happen every 1 second, 1000 milliseconds? 1, 2, 3 seconds, that works. I set it back to 150 milliseconds. This timer is actually not completely accurate, because every time we reset timer back to 0, unless the timer was exactly 150 milliseconds when it was reset, we are losing some milliseconds that were over that value. Let's say the timer gets to 160, and then we reset back to 0. We lost those 10 milliseconds between 150 and 160. We are not accounting for them anywhere. It might be fine and it might not be a big deal for simple projects, but we can easily account for them using a modulus remainder operator. The remainder operator returns the remainder left over when one operand is divided by a second operand. Instead of resetting event timer back to 0, we reset it to whatever was left over 150. This will improve the accuracy, but it's some extra calculations we are asking JavaScript to do. It's your choice if you want to sacrifice a little bit of performance for increased accuracy or not. I'm going with this. I console log that remainder event timer after each reset, and you can now see we were losing around 10 milliseconds for each event interval cycle. Now we are accounting for that. The remainder operator returns the remainder left over when one operand is divided by a second operand. I hope it makes sense. Now we have this event update property, and we can use it to time things in milliseconds instead per animation frame, which will make sure that, for example, the energy recharges at the same speed on all devices, regardless of the device's ability to serve animation frames faster or slower, regardless of the device's screen refresh rate. Only if event update is true, we run this code block. Instead of running this once per animation frame, different devices can serve animation frames at different speeds. We will run it every 150 milliseconds, which we know will be consistent on any kind of device. Now I have to adjust these values, of course. The rate at which we deplete the energy always has to be more than the rate at which it recharges. Otherwise, we can use our special ability all the time with no limits, and we don't want that. I will try +1 here and -6 here. I can change that later. We can start charge by pressing Shift or C. I also want to allow the player on devices without a keyboard to use it to play. When on mobile, the player will flap when we tap the screen on touch start event, and it will charge on horizontal swipe across the screen. To measure the length of a swipe, I will need to keep track of the horizontal x-coordinate where the touch started. I will console log this touch event. We are in Google Chrome, so I can click this button, toggle device toolbar to emulate a mobile phone. I trigger a touch event by clicking here. I'm looking for this changed touches list, index 0, and inside we have a lot of information about the touch event. For example, this page X property, which gives us a horizontal coordinate of the touch. I add an event listener for touch move event. If event.changedTouches index 0 and its page X property minus touch start X, if the difference between them, between where the touch is now and where it started, is more than 30 pixels, we know that the user swipe was long enough. I console log something, XXX. When touch start event fires, we set touch start to the page X coordinate. That will be the starting one. When we swipe on a screen on a device, the first contact will trigger touch start event, and as we move our finger around, touch move event keeps firing until we lift our finger, and that's when touch end event fires. As we start, we save the initial horizontal coordinate of the touch in touch start property, and as we move our finger around, as we swipe, we are comparing the current position to the starting position. If we swiped far enough, more than 50 in this case, it will trigger this code block. I delete the console log. So when I swipe horizontally, we get this XXX logged. Instead, I will call this.player.startCharge. I can use this button to rotate my device. Tapping the screen will make the player flap. Horizontal swipe that is more than 50 pixels will make the player charge. Let's put this into a variable. I call it swipe distance. I define it here and I set it to 50. Let's test it. Yes, it still works. So this is a very simple way how to implement directional swipe controls. We can also attach different player or game actions if the swipe is vertical. We can separate left and right swipe, or up or down swipe, and so on. I make the energy recharge slower. I can make the player react to the environment. For example, when we hit an obstacle, it will stop charge. 5 obstacles. I play, I avoid the first obstacle, I charge, I hit an obstacle, and the charge ends on impact. Maybe I want to do a charge move that feels more powerful. We only apply gravity when charging is false. If we are charging, not only we are not increasing gravity force, we even reset speed y to 0 so that the player is not pulled down by any force. And until we finish charge, gravity will not affect us. This should feel different to play now. When the player collides with one of the obstacles and triggers a game over, I want the obstacles to stop bouncing up and down and just to fall off screen. In that update method on obstacle class, I only run this code that bounces obstacles if game over is false. If game over is true, this else block will run instead, and in there we will endlessly increase speed y by 0.1, making them fall off screen. I added this OR statement to is off screen method. If they scroll past the left edge, or if they fall off screen vertically, in both cases we delete the obstacles from the array. I play, I avoid the first obstacle, I collide with the second one, game over triggers, and as they all fall off screen, I can see the obstacle array empties. We have a complete game without graphics. You can use this as a skeleton for your own game and add your own unique graphics, player images, obstacle images, and a different background. I delete this console log. Or you can follow me in the next section and add an animated player character, obstacles, and so on. In this blank base project, we already implemented so much. We have restart, full screen, and debug mode. We count score. The player needs to manage a rechargeable energy bar by using its special ability efficiently to beat the race course in the shortest time possible. You can create a copy of the project folders at this stage just as a backup, so you can use this for other games later. Now we are turning this Flappy Bird into a steampunk themed Flappy Fish game. You You can download all project images in the resources section below. We are on a steampunk planet. The life forms here are living machines. Our player character will be a rusty mechanical fish made out of valves and gears, and the wings will be parasols. I created another character, an Antigravity Boar. It can flap by reversing its magnetic field. I will also experiment with a different type of sprite sheet for that character. That one will be available in an extended version of this class. I give the image an ID and I point its source towards the sprite sheet. It's inside my assets/images folder. I give the player class this.image property. I use built-in drawImage method we already used to draw the backgrounds. It needs at least 3 arguments, the image to draw and x and y coordinates where to draw it. When we do that, it will simply draw the entire image from those x and y coordinates. Keep in mind that when we draw images and rectangles on canvas, x and y coordinates define the top left corner. When we draw a circle, x and y coordinates define the center point, around which the circle is drawn. If I scale the canvas, you can see the image also stays at the same size. The sprite sheet is very simple. Each row is one player action: idle, wings down, wings up, and charge. Having a very simple sprite sheet will help to increase performance, and it will still look good because we will animate between these rows dynamically and often. We can pass a drawImage method optional width and height arguments. Whatever values we pass to it as width and height, the image will be squeezed or stretched to fit into that area. Now we are squeezing all 4 frames into an area of 1 frame. We will use the longest version of drawImage method that gives us full control over the image. We pass it the image we want to draw, source x, source y, source width and source height of an area we want to crop out from the source image, and destination x, destination y, destination width and destination height of an area on destination canvas where we want the image to be drawn. Let's say I want to crop out this frame from coordinates 0, 0 to sprite width, sprite height. These values have to exactly match the size of a single frame in the sprite sheet. Our frames are 200 × 200 pixels. The size of the image we draw doesn't have to match the sprite sheet. It can be scaled up and down. So we define the image, the area to crop out from that image, and where to draw it on canvas. Because I'm using width and height here, we already scale these values by ratio from before, so the image scales as well. I can remove the stroked rectangle. I want to draw the obstacles. You can download the image in the resources section below. I give it an ID small gears, and I will point the source towards the image file. We will do something similar here. I give obstacle class this.image property. The obstacle sprite sheet is 4 different gears aligned next to each other horizontally. I want each obstacle to be randomly assigned one of these 4 images. drawImage method. We know that passing it just 3 arguments will draw the whole image. We also learned that by passing it optional width and height, it will distort the sprite sheet to fit into that area. We are already scaling the width and height from before, so it also scales the images. I want to crop out 1 random gear for each obstacle: source x, source y, source width, and source height. Let's start by cropping out this one, the left gear. Crop from coordinates 0, 0 to 120 width and 120 height. The obstacle sprite sheet I prepared here has frames 120 × 120 pixels, sprite width and sprite height. Now all the obstacles will look like the gear on the left in the sprite sheet. I can remove these black rectangles. Source x argument defines the start of the cropping area horizontally. If I say 1 × sprite width, we move the cropping coordinates here and we draw the second gear. 2 × sprite width, 3 × sprite width. I put this value into a variable I call frame x. Frame x0, frame x1, 2, 3. As we create the obstacles, we will give frame x a random value between 0 and 4, but that will give us decimal points. We don't want to crop out from 1.5 × sprite width. We need integers. Whole numbers with no decimal points. So I wrap this in math.floor to round the values down to the nearest lower integer. Now, as the obstacles get created, each one is assigned one of the 4 frames in the sprite sheet randomly. It will all scale with game height correctly. Obstacle frames are organized horizontally. Player frames are organized vertically, so if I want to travel between those frames, instead of source x argument, I will adjust the values we pass as source y. 1 times sprite height will give us wings down, 2 times sprite height is wings up, 3 times sprite height is charge. 0 times sprite height is idle. I call this value frame y. By changing the value of frame y, the vertical frame, we can animate different player actions. When we resize, start or restart the game, the player will be set to idle state. Also, if the player was charging during the reset, we need to make sure charging is set to false. Now I need to swap between these sprite rows from different places around the codebase. It can be done like this in a smaller project we have here. In a bigger codebase, it can become too complicated and convoluted, so state design pattern would be the best solution here, to keep the code simple, modular and organized when swapping between different player states. I will keep it simple today. When we start charge, we set frame y to 3. That works, but to make the code more readable, I will actually delete this and I create 4 helper methods. Wings idle, wings down, wings up, and wings charge. It will make it easy to read the code fast, and it's good for clarity as we are developing it. Idle is frame y0, wings down is frame y1, wings up is frame y2, wings charge is frame y3. When we charge, I call wings charge. Yes, inside update method, so this code will run for every animation frame, I will be checking if speed y is more or equal to 0, meaning the player is moving down. If so, we call wings up. But now when I charge, I still get this line. I can probably say more than 0, but not equal. Or I can make these methods change frames only when charging is false. Okay, we start in idle. We can animate charge. When the player is falling down, the wings go up. When the player touches the bottom, I want it to animate idle state. Wings idle. Charge, fall, idle. Yes. When we flap, we call wings down. I try to play. This already looks pretty good, but if you are coding along, at this point nothing happens when I release the flap input. I guess I want the flap to animate wings down, but only as long as I hold that input key. When I release it, I want something to animate as a reaction. What if I put wings up here when mouse down event fires? No, that's not going to work. I copy this code block, I turn it into mouse up. Mouse down is flap, so wings go down. As soon as I release the mouse button, we move the wings up. Yes, this feels really good and reactive. We have only a simple sprite sheet, which is good for performance, but it reacts so quickly and so often to my controls and to things that happen in the game, it actually feels great. I like how it works with mouse. I want to replicate this when we are controlling the player with keyboard. I copy this, we attach it to the window object. On key down, if we press the correct key, we flap. I want to keep this simple. On any key up, we call wings up. I could also do this for touch end event, but it seems it is triggering mouse up from line 51 even when on touch-based devices, so all seems to be good here. I need to do a proper cross-device testing. There might be some niche mobile browsers that actually need the touch end event to be defined to call wings up. I recommend using Google Chrome or Firefox. Apple doesn't care enough about their Safari browser to bring it up to date with modern web standards, and in my opinion, nobody should ever use Safari. That's my hot take. We have animated player fish, and we have this collision circle that we can show and hide by pressing D, debug mode. The collision circle travels around with it and is always positioned relative to the player position, but we can adjust its size and position to better match the sprite sheets we are using. Let's say I have the wings and tail, but I don't want to detect collision on those body parts. I only want to detect collision on the main fish body. I set collision radius to 40 pixels. Of course, hard-coded 40 pixels will not work in this project. I always have to account for the current game ratio. Now it scales correctly. I can also move it around. Maybe I want it to be over the head and main body of the fish, so x plus 40, 50. Again, we can't do hard-coded values. I can do just times ratio in here, but that would force JavaScript to calculate the same value over and over 60 times per second. Not good for performance. We only want to recalculate ratio when resize method runs. That's where we pre-calculate everything. I could use a portion of the collision radius, for example. This would work. Not 100% ideal. I am not pre-calculating that. It would be better to pre-calculate this and not make JavaScript always do radius times 0.9 over and over for every animation frame. The size of collision circles around obstacles can affect the game difficulty. I can make them smaller to make the game a little bit more forgiving. I delete this from here and I will put it here. If the circle is smaller, the game is a bit easier because the image of the gear is bigger than the collision circle. So the player can actually touch the outside of the cog image without getting a game over. I can do 0.3 here, but now we can say it is a bit too forgiving. This game is starting to look pretty good actually. We learned so many things and these building blocks and techniques can be used to build literally thousands of different games. I structured this class to give you as much value as possible. Let's add audio. Sounds are an important tool in game design. For example, when the player charges, we give the user visual indication by animating the sprite sheet of the character into a charging state, and we can also play a sound to confirm that way that the action was taken. I created a set of MP3 files we can use in this project. You can download them in the resources section below. I add them into my project folders, into assets/sounds. I give this one an ID of charge. I create another script file to keep our project nice and organized. Here we will have a very simple custom class called, for example, audio control. In index.html, I included the script file, audio.js. Constructor will have one property for each sound file we will be using. This .charge will point to that MP3 file we included using its ID. I bring that into our main game class here as this.sound. This will allow us to play these sounds from anywhere all over the codebase. So when start charge method runs, I run this.game.sound and we call this charge.charge.built-in play method like this. I play, I press Shift or C to activate player's special ability and we get a sound. Perfect. Ignore this favicon warning. I'm not doing a favicon and for some reason my dev environment decided to complain about it. It's not relevant to anything we are doing today. The problem with this implementation and with how playing audio files is handled in browsers is that when I stop charge and I charge again before the first sound finished playing, I will get no sound. If I want to play the same audio file again before it finished playing, the browser will not do it. The best way I think to handle this is that I can always rewind the audio to the beginning before it plays again. It will solve this issue and it will work really well. Let me show you. I create a custom play method. This method will take sound as an argument, for example this.charge reference, which points to the actual MP3 file. It will take that sound file and it will first rewind it to the beginning by setting its current time property to 0, and only then it will call built-in play method to play it. This is my custom play method. This is a completely different built-in play method. I hope it makes sense. So we know we have to call custom play method and we have to pass it a reference to an audio file we want to rewind and play. This.game.sound.play, and as the audio file reference I pass it this.game.sound.charge. Now it works exactly as I want it. I can press chargeability over and over and it always plays the sound from the beginning. I want to give the player kind of a cooldown. If the current energy is in the red, we will not be able to activate charge. Only when we have enough energy, More than min energy, I guess, because otherwise we get this weird charge just for a fraction of a second, and then we run out of energy and we get kicked out of charge. I want to prevent that. We can only activate charge ability if we can sustain it for more than a fraction of a second. If the player is already charging, we don't want to play the sound again if we press the button again. If we press charge button when the player is already charging, we will end charge. Now we can interrupt the charge ability by flapping the wings or by pressing the same charge button again for the second time. This gives us even more control. This feels really good to play actually. I noticed that min energy doesn't match the red color breakpoint. Okay, it's because I hard-coded 20 here. I need to use this.min energy here instead. Okay, we are playtesting, we are tuning, and we are tweaking. This is good. Let's play a sound when the player flaps wings. I included here in index HTML. I create a property for flap1 inside audio control class. When we flap, I call our custom play method to first rewind the audio to the beginning and then to play flap1 audio file. I play, we get a sound when I flap wings and when I charge. This is good. Actually, let's only play the sound when we animate the wings in this code block. Even better now, when we are flying by the top. The flap sound will play a lot, it will be played frequently. Maybe we want to introduce some variety. How about I import 5 different flap sounds, similar but different, and whenever we flap wings, I want to play one of these 5 available randomized flap sounds. Flap 1 sounds like this. Flap 3 sound. I create a property I call flap sounds. It will be an array, and I put all 5 of them inside, like this. Now I call play flap sounds index 0, index 1, index 2, index 3, index 4. So let's play a random one. There is no index 2.5 in the array, for example, so I need to round the random number down to the nearest lower integer. Now it will give us 0, or 1, or 2, or 3, or 4. I need to be careful about brackets when I do this. Now, as we play and we flap wings, we are getting randomized flap sounds. I also include a sound for when we win a game and when we lose. This.win property, this.lose property. When we collide, we play this.game.sound.lose. I play, I collide. The sound is delayed. I will remove it from here. Instead, I will call triggerGameOver method. We will write that method soon. If there are no obstacles left, we call triggerGameOver as well. I will actually put that method on the main game object, so I have to use game.here here and here. I define that method here. I want to play a sound from here, so I need to make sure this method runs only once, because if it runs over and over for each animation frame, we would get a sound that repeats. I can make sure it runs only once, for example like this. When this method is called from obstacles.js, as we just wrote it, it will only run its code if gameOver is false. And inside, when we enter this code block, I immediately set gameOver to true, preventing this method from running again, because if called again, this first check will fail. Inside, I need to check if the game was won or lost. If there are no obstacles left, we play the win sound. Else, we play the lose sound. I set number of obstacles to 1 or to 20. I set collision radius on the obstacle to 0.4, I guess. Line width can be 1. Inside trigger game over method, I can also set the messages. Because this code runs over and over for every animation frame, we actually need to run this code only once when game over happens. Losing message, winning message. And I can delete all this code. I play. Yes, it still works. I will go with 15 obstacles. I want the player to rest at this line to match the environmental artwork better. Bottom margin property, it can be used for other things as well later. Maybe if the obstacles break into smaller pieces, this value can define the floor from which they will bounce or something like that. The value will have to scale to keep matching the background artwork when that scales. Let's try 50 pixels from the bottom times game ratio. Again, this has to be declared after the ratio was recalculated on line 88. I will round the value down with math.floor. We want to avoid decimal points as often as possible when drawing shapes on canvas. We have this helper is touching bottom method. I will account for the new scaled bottom margin value here. We also have this hard boundary to make sure the player can't fall any further down. I need to include bottom margin here as well. Now, the player will rest at this baseline. We can set it to anything we want. If I do 250 from the bottom, we get this. 50 pixels seems good. Let's see if it works even when scaled down. Yes, the player still follows this line on the background artwork. This is good. I discovered a bug. When the player is touching the bottom and I charge, the sprite sheet stays in idle. It doesn't animate the charge move. I can fix it easily by only switching to frame Y0 if the player is not charging. State design pattern would be ideal to handle the player states here. I will implement it in the next project. I think we learned so much in this class already. If I charge when the player is at the bottom, it will animate correctly now. You might have noticed that the font sizes don't really scale. It might be fine actually, but if I wanted the fonts to also scale, I have to make sure the text size and the margins around the text are calculated with the current game ratio in mind. I can create small font and large font properties. These will be globally available all over the project because I'm putting them on our main game class, which is kind of a simple state manager in this project. I will use only 2 font sizes for all the text in the game to keep it simple. Should be more than enough. Again, we need to adjust these to the current ratio, so inside the resize method, after the ratio was calculated, small font will be 20 pixels, large font can be 45 pixels, and we don't want to draw any sub-pixel values. We don't want font size 45.6 for example, so I will round these values up by wrapping them in math.ceil built in JavaScript method. This method will round the values up to the nearest integer, to the nearest number without any decimal points. Inside the draw status text, I use the large font for the main big game over message. I concatenate large font value plus pixels bungee. For the 2 smaller game over messages, I use small font px bungee. We are offsetting vertical position of these 3 lines of text to align them on top of each other. I need to make these values also relative to the ratio. I can create new properties for these offsets, or I can use some current property we are already scaling. I can offset it vertically by minus large font size, like this. The second line will be minus small font. And the third line will just stay where it is in the middle, no offsetting needed. I play, I hit the obstacle to see the game over messages. Yes, this seems alright. Toggle device toolbar button in Google Chrome browser to emulate some mobile devices. I want this game to be played mostly in landscape mode because while in portrait mode like this, you can't really see far ahead, so it is hard to avoid obstacles. But since this game is fully responsive, it needs to work even here, and I need to prevent this text from overflowing. There is a very simple built-in solution for this. Fill text method can accept an optional fourth argument for maximum width of the text. So I pass the width of the game to all three messages. This means if the message is wider than the current screen size, JavaScript will squeeze it a little bit to fit in, but only if needed. I like this solution. Quick and simple. On mobile devices, I want this game to be played in landscape mode like this anyway. But at least it doesn't look broken and the text is readable even in the portrait mode. We scaled game over messages. I also want to scale the timer and score text. In the resize method, I set the global canvas font to this.small font plus pixels bungee. This line needs to be called after the small font size was recalculated. I can keep the hard-coded margins for timer and score, but ideally these should also scale, so I will use our existing scale small font and large font values as the margins, which will work really well here. Left margin small font, top margin large font. Now all the text is fully responsive and it scales up and down with the game text. What I realized just now is that we don't even need clear rectangle to delete old canvas paint between every animation frame, because we are redrawing the updated background image for every animation frame, which effectively covers the old paint anyway. If I comment this out, we still see the normal animation. I actually can't do this because the collisions are detected on collision X coordinate, and by doing this, I'm drawing the collision circle somewhere else, not at the exact position where the collisions are being detected. Instead, every time we resize, I have to adjust the collision X property itself to make sure the area where we detect collisions and the collision circle we are drawing are always on top of each other horizontally. That's better. If I play on a mobile phone or any other touch device, I notice the way I implemented the controls is not ideal. Sometimes the charge gets interrupted or reset because we are dealing with it here. So if the touch move event runs long enough, it will start and it will stop the charge even when we don't want that. I can fix this by creating touch end event. We will only decide if we want to charge or flap after the entire event sequence ended. Touch start will just set the starting coordinate, so we can use it to measure swipe distance. Only when the entire gesture was finished, so touch start, touch move, and touch end sequence played out after user swiped or tapped the screen, only then we will look at what happened. If the swipe was long enough, we activate charge. If it was short or just a tap, we flap. I call prevent default here to stop the screen from sliding on some devices. Now, the wings no longer animate down when we flap with mouse or touch controls. Keyboard controls are unaffected. I can fix it, for example, by using built-in JavaScript setTimeout method. It takes a function to run and a timeout value. How many milliseconds it should wait before that code runs. When we flap, the wings go down. I will wait 100 milliseconds and then I will put the wings up to create the wing flapping animation. I'm using ES6 arrow syntax for setTimeout here. For this to work, I have to remove this line that triggers on mouse up, because apparently mouse up event is also triggering on touch end. Now it works on touch devices, and our charge move is much more reliable and easily to trigger and interrupt whenever we want. I test mouse. Mouse up event doesn't run on setTimeout, so it doesn't work here when I flap with mouse. So I copy this and I put it inside mouse up. Timeout may be only 50 milliseconds, so we can flap faster. I will also set it to 50 milliseconds down on line 85. Or, because it seems that touch end event triggers mouse up event anyway, I don't even need set timeout here. If you want more, I made an extended version where we control Antigravity Boar, linked in the description below. We will learn how to animate parallax backgrounds and more complex character sprite sheets. All my extended classes also have full source code and a lot of bonus game art. Click like if you found some value. Let me know if you got all the way here by saying I did it. I will respond to every comment on this video, so just say hi if you want. Thank you to everyone who supported me by using the links below to buy my extended classes. It allows me to make more free content here on YouTube for everyone.